Hello, my name is Darshan Shah. I'm the head of product and CMO at Protempis, and joining me today is Edward Rodemsky, VP of Sales, and Mario Ramirez, who is a field applications engineer with Protempis. And we're going to be talking about how you can optimize the performance of your deployment using precision time and PTP sync for the latest requirements. Let's dive right into this topic. So I want to start with a real life case study. So over the last 3 years, Protempis has heard from a number of different organizations that are involved in private 5G deployment. These organizations are typically being tasked to replace Wi-Fi with 5G. Now, why is that? Because with 5G, you have longer distances, you have better security, and there's a better quality of service when there's lots of clients. And over these last 3 years, there's been some common requests that we have come across that we want to share with you. We're presenting this in the form of a checklist on your left side. So those include being able to address 5G densification, having a higher PTP client count for scaling purposes, compared to the solutions that have been around for the last few years. Being able to integrate into a 10G networking environment, being able to meet budget constraints. Wi-Fi is a legacy technology, so 5G can't be a significant adder to that. Form factor is always important because rack space is at a premium. Security and certifications have really become more important recently with all the hacking going on. This is now an area that solutions have to really be able to meet those vulnerability and security requirements. Easy manageability is really important because when private 5G deployments, it consists of multi-vendor solutions. And so having to deal with multi-vendor means you want easy manageability and configurability. It should some component go down in the multi-vendor solution, want to have solutions that can and components that reduce downtime. So it's very rapid to diagnose a problem and then get back up and running. And then a common one that we hear is customization, that, everyone has their own unique use case requirements. And so customizations are really attractive solutions that have that capability. And we took that all into account when we were designing the Thunderbolt GM330, which you're seeing on the screen. It really was developed to meet the latest and most stringent time and sync requirements across different market segments that really that are pushing the envelope. And we're going to go through what those segments are in just a second. Now, we have deployed the GM330 to a number of early adopters, and the feedback has been very positive. So when we look at how this compares to the checklist that I presented, this product is able to meet the densification requirements because the stability is so tight, plus minus 5 nanosecond. There's over 128 PTP client capacity, which is larger than most of the solutions that have been out there. And this means that this product can scale. It meets budget. When you look at it from a total solution perspective, it has a small footprint. We'll show you what we mean by that. It even can eliminate a 10 gig switch. And we'll talk about that in just a second as well. And because it's an evolution of a successful prior product, it has been able to easily meet security, vulnerability, and certifications. It has a GUI that makes manageability and configuration easy, and serviceability through its alerts and logging are also very intuitive. And that brings us to our agenda today. So we're just going to tell you a little bit about us, 1 minute, and then we're going to talk about the latest time and sync challenges that we're seeing across the industry and across different market segments. We'll then go into the Thunderbolt GM330 and give you a deeper dive into that. We're going to have a demo of the GUI. It's only going to take about 2.5 to 3 minutes. And then the best part of the presentation is going to be different use cases that Edward is going to be presenting across a bunch of different market segments. So stay tuned for that. And at the end, we'll have some resources for you to learn more. Now, a little bit about our company. So our organization has been around for over 3 decades, and it started off with GNSS timing technology, and it's evolved to network synchronization, which is what we're going to be talking about today. Across that time period, there's been millions of deployed devices, and the organization's been very well known for its very high reliability. Now, the previous name of our organization was the Trimble Time and Frequency Division. 2 years ago, the division got spun off to a private equity company called the Jordan Company, and the new name is Protempis. But we still have the same DNA, a lot of the same people, and the same product lines are being supported, but with more innovation focus now that the company is on its own. Now, across these 3 decades, we have worked with just about every market segment that needs time and sync, and we've provided innovative solutions across the board. This is just some of the popular segments. And of these, of all of the segments, there are 4 that we are seeing that are really pushing the envelope on time and sync requirements. And those are the private and public wireless and ORAN, and those are really rapid growing areas as well. So those are both multi-billion-dollar segments with 30 to 50% CAGR growth, and time and sync is a portion of that. But nevertheless, these all require the latest in time and PTP sync. Industrial and small cells is another area. Some of that is being modernized because of operational technology improvements that the government in the U.S. is mandating. Another is there's use cases in data centers and also emerging segments like AV that require the latest in time and sync. And so since we work with customers in all of these different segments, what we want to present here is kind of what are the commonalities in the time and sync challenges that we're seeing. And so all of these solutions have a need for very accurate time source and GNSS-based time sources. And so what we're hearing typically across segments is the need for tighter timing accuracy, a multi-constellation, because a lot of these solutions out there are global and they need to be able to work regardless of geography. Longer holdover times is attractive in some use cases. And then really important is the latest in anti-jamming and anti-spoofing for security reasons. Now, on the synchronization side, that's where PTP comes into play. 2 of the most common areas we hear about is a client count client count capacity that is better than what solutions in the last couple of years can offer, and also solutions that can support a wide range of PTP profiles, because different market segments have different needs for optimal performance. And so being able to address those regardless of segments is very important. On the networking side, integration into 10G and higher networks it comes up a lot. And then, of course, what we talked about earlier, ease of management, configurability, and ability to customize to unique use case requirements. And finally, just general budget, fast deployment time, fast serviceability, small form factor. And so the GM330 was designed with all of that in mind. And if there's one takeaway that we hope you'll get out of this presentation, it's the words integrated functionality. So this product integrates the latest in GNSS timing with the latest in PTP synchronization and distribution, and it also integrates a layer 2 switch, and it has 10 gig ports. So it provides a lot of benefits. And let's go through each of these individually. So the GNSS timing receiver that is integrated in this product is based on a popular receiver called the Res 720. Protempis has had that product out over the last couple of years. And what makes that receiver special is it's dual band. By being dual band, you get tighter stability, and it also provides additional resilience for anti-jamming. The receiver also has world-class holdover technology that's longer than prior products can involve, and it's multi-constellation. The PTP sync module was designed so that the product can be used in different modes. It can be used as a Grandmaster, it can be used as a boundary clock, it can be used in free run and more. And it includes all of the most widely used PTP profiles that you see in the gray box. And it also has a higher PTP client count, 128 to 4,000 capacity, depending on the transaction rate and the PTP profile. It also has NTP support. And then finally, there's a 40 gig layer 2 line rate switch that's integrated into the product. And there's 4 10 gig SFP plus ports that can accommodate either copper or fiber inserts. There's also an additional 2 1 gig ports, and the product can be powered through PoE plus. This is the front panel of the device, and on the left side, it has everything that you typically need for timing, whether it be PPS, frequency, or time of day. And the right side shows the different ports that I just described. This is the back panel of the product, and it has the GNSS antenna input and more. And then in terms of form factor, it's just 1 RU tall, and it's a half rack width. So you can fit 2 of these side by side, which is really useful and space saving for redundancy. And we built the GUI with a lot of different management, configuration, and security capabilities. So in addition to the GUI, there's a Cisco-like CLI. It has API support for all the most popular protocols. It's got ZTP support, so you can do functions like call home. And it has security built everywhere that is needed. And what we're going to do now is play a 3-minute video from our field applications engineer, Mario Ramirez, of the GUI, so you get a feel for it. And as you can see, the GUI is organized just with those integrated functions in mind. And then there's additional functionality for fast diagnosis of issues and other. So I'm going to go ahead and play this video, and then we'll resume the presentation.
This is a demo of the GM330, highlighting the most interesting features. Once you log in, you'll be taken to the GNSS status screen, as you can see here. This screen has everything you need, including a time summary and location information. If we change to the satellite screen, you have a comprehensive satellite information, including the satellite status. Since our receiver is a dual band, you'll see all the satellites for the L1 and L5 frequencies. Now, if we look at the sky plot, you'll get the real-time view of the satellites, including the SNR value or the signal strength. You can hover over one of the dots to get more information. In the tracking screen, you get a real-time snapshot of the number of satellites being tracked and the number that are being used in the calculation. Now, if you move to the network screen, this gives you the full status of all the 6 network interfaces. Here you can see I have 2 connected, Ethernet 0 and Ethernet 1, so everything is up. And you can see that I have nothing connected on the other 4 interfaces. You get an idea of one of them is a DHCP, and the other one is a Ethernet. Ethernet 1 is a static. Now, if we go to PTP, you can choose the profile. So, for example, one of the popular ones are 8275.2. So, if we choose that, we can assign it to any one of the 6 interfaces. Also, there's other parameters that you can set. You want to probably set this to match your target to make sure that you're able to communicate properly. Now there are other screens like events. So anything that has happened to get logged. So you can look at this to see if you have any alerts or errors or anything like that. Also, you can actually filter on certain events. Now here's the alarm screen. So you can see all the alarms that have occurred. Also in system, this is a very important screen. There is this support area here. You can download a diagnostics file that you can send us if you're debugging an issue and you want us to help you. We might request this file. So you create it and then send it to us. Now here is under the update screen, you can see that this screen is used to upgrade the firmware. So here you'll choose, if we send you a new image, you'll be able to choose where it is, and then you can set it, and then you could download it or upload it. Yeah, so that's it. So this is basically the new GM330 web UI. As you can see, it's very intuitive. This is all for the quick demo. Thank you.
Okay, and I would just add that if any of you that are watching are interested in a demonstration of this GUI for your specific use case, we're happy to do that, and we're going to provide contact information at the end of the presentation. Now, this product is available as a complete kit with antenna, cabling, and everything else that you need. So there are specific part numbers that to look out for the specific kit solutions. And this is the complete packet timing portfolio that Protempis now offers. So we have an NTP server, and then the GM200, very popular product. It's the prior generation, essentially, to the GM330. And if you look across all of these different rows, you're going to see that the GM330 really takes the performance to the next level. And we're going to be planning to support the GM200 for a long time to come. So you have a choice now. And the pricing for both of these is based on the performance. So if you don't have as much of a stringent performance need, the GM200 may be adequate for your needs. If you have a GM200 and you want to be able to upgrade to the GM330, you have a seamless upgrade path. And if you just need the higher performance needs, latest time and sync, the GM330 meets those really well. So now we're going to shift gears to different use cases for different market segments. This is the best part of the presentation. I'm going to go ahead and switch over to Edward Rodemski. Now, Edward has been in the industry for over 30 years, so he is an expert in time and sync, and he's going to talk about how to think about time and sync solutions for these different types of deployments. And then we'll come back and go through a conclusion after Ed is completed. All right, please take it away.
Thank you, Darshan. The GM330 is used as a Grandmaster in a variety of applications. In this particular one, this is an indoor enterprise application where it's used to synchronize radio access points. And so the radio access points can be thought of much like the same type of use as like a Wi-Fi router, but with better capabilities, and it allows you to have higher coverage areas, also better performance. And so these radio access points then can be scattered throughout the enterprise, and then they're all synchronized and timed using the GM330. The GM330 also, because it has a built-in switch, can take the place of the access switch. And so now you can have all of your data run through these radio access points back into your network. In this example, this is a campus type of environment where you've got individual buildings or warehouses that are outfitted for its coverage, and then they're all linked together in one wide area network and then connected to the backhaul. And with this, you can use the GM330 again as your switch, as well as your PTP Grandmaster. Here's an example using what's called CBRS, which is a private wireless deployment in a retail industry where you've got various malls or department stores around the country, and then you have the data connected through a data center, and you now have the GM330 as your Grandmaster, synchronizing the transfer from the data center to the remote location and back. This example here, we have what's called communications-based train control. So as different industries take on levels of automation and the higher throughput requirements, this is an example of one of those where you actually have a time-sensitive network where things have to happen on time. They have to happen in a certain way because you have operational requirements of the train to control it, safety, as well as operational concerns. Here we have various wayside radio units, and these kind of act as the same as the radio access points. And so you have the wayside radio unit talking to the train, and then it's all connected back through the wayside network, and then all the way back through your automated train supervision control system. PTP is being used in a variety of different industrial applications. We talked about several already. We talked about an enterprise one, automated control with the train, retail, and we can also use it in with the smart grid. And this is in the power industry, particularly the electrical generation and distribution. And the requirement here is for a cost-effective, reliable clock that can synchronize all the different elements within the substation, as well as along the transmission and distribution side of it. So you can do everything from the power generation through the distribution and then the substation. And so this type of application, you have a full communication network and control monitoring system, and all the different elements within the network need to be synchronized, and the Grandmaster can provide that. In the broadcast industry, they use this PTP as well. This particular one you have for particularly for video, but it can be used for audio as well. And so you got a variety of cameras that are all what's called PTP ready. And so they're automatically ready to go and looking for a PTP synchronization command in order to integrate within the network. And what these applications show is how a variety of different industries can all specialize on using PTP. And so what the standards organization, the IEEE 1588, what they've done is they have a variety of different profiles that are available. And each profile is kind of a standard configuration meant for a specific application market segment. And so simply by picking these different profiles, you can then have yourself ready for power or utilities, broadcast, time-sensitive networking, all the different types of applications. And so the GM330 is a highly versatile device that can be used in all these different profiles. One of the last ones is the autonomous truck. Here you have a variety of sensors and LiDAR that are all, again, being come PTP ready. They all need to be synchronized, and the framing and the data all needs to be fused together. And so you use time stamping and other kinds of synchronization methods to be able to bring all this data together in order to provide the autonomous control for the vehicles. And again, this is one of those profiles, and you can pick a specific profile, then you're all set up for autonomous operation. One segment within the telecom wireless market is ORAN. This stands for Open Radio Access Network. And so this is a way for various vendors to provide compatible products and different type of networking devices to the industry. The idea here is that by having ability for multiple vendors to create compatible products, that you would have more competition, better innovation, and have a way to bring in a variety of different network solutions. Typically in the past, you would only get an end-to-end solution from one particular vendor. Now you have the ability to mix and match different networks devices and really optimize the performance of the network by picking different types of network devices. But one common requirement of mixing all these types of products is that they do have to be synchronized. They have to meet the 5G standards, and they have to be synchronized. One of the main requirements is timing accuracy and being able to put 1.5 microsecond worth of accuracy all the way out to the edge of the network. And so they've come up with different configuration standards to follow that allow for network timing distribution to happen. This first one here is called C1. And in C1, you have your network timing distribution from what's called the distributed unit out to the radio unit. And so in an ORAN approach, you really have three devices that kind of are disaggregated from the way that it was in the past with standalone base stations. And now you have more like servers, and they're called the centralized unit, the distributed unit, and then the radio is out at the end, which is called the radio unit. So in this particular case, you're taking time from the distributed unit and sending it out to the radio unit using one of the telecom profiles, wireless profiles. You can have the synchronization either part of the distributed unit, kind of maybe like an all-in-one concept, or you can have it as an external interface like we show here in the diagram, where you've got the Grandmaster providing the local sync to the distributed unit, and then it forwards it out to the radio unit. The next configuration is C2. And here you've got network timing that's being distributed from the distributed unit out to the radio unit, but you're doing it through a switched network where you have a switch in between the DU and the RU. This allows for, multiple RUs to all be controlled, and you've got the switch then kind of providing aggregation functions. And so here we've got the Grandmaster provide local sync to the distributed unit, and then it provides it out to the switch, and then the switch routes it to the radio unit. The third configuration, C3, this is where you have a front haul switch acting as its clock source for the network timing. And what you've done is this kind of shows that you can insert the time and sync in multiple places within the network. And so the network engineers, network planning professionals, they can really kind of look at their network and where they need to have the synchronization inserted, with the idea is that you have to have this accuracy all the way out to the edge of the network. So in this particular case, the Grandmaster provides the local sync directly to the front haul switch, and then the front haul switch sends that sync either out to the radio unit and even back to the distributed unit. And then the C4 configuration, the last one, where you have the local time and sync is in the actual radio unit itself. And the DU has no need for the timing distribution. And so you can have the network really provide the accuracy right at the edge because you're putting it right part of the radio unit itself. This tends to be maybe for smaller deployments where you don't have a lot of network devices in between, not a lot of hops. But then you can also then have that sync provided to the backhaul network, to the rest of the network, by sending it to either the CU or the DU with a standalone device. Here's another example of the C4, where you can then have the time and sync provided to multiple devices simultaneously directly, but there's no requirement for distribution between them. So this is option 2. And with that, turn it back over to Darshan.
I thank you very much, Edward, and hope all of you found that very informative and educational. If you have any specific use cases that you'd like to describe, we're always happy to talk to you, consult with you on what might be a good time and sync solution approach for you. So please contact us, and we'll provide some resources on how to get in touch. So I just want to conclude with a couple of key points here. So I had mentioned that the GM330 has been utilized with early adopters, and I wanted to share some of the feedback that we've gotten. It's really 3 different categories of feedback. So the first is that our early adopters are really seeing the savings, both in cost and deployment time, and that's because of the integrated functionality we talked to. It reduces discrete components, which integration always makes things a lot faster to deploy. And we get this feedback all the time. The product is at a very competitive price point. Secondly, the optimized performance has been very compelling. So the tight GNSS stability that Ed talked about, the higher PTP client count compared to what's been out there for the last couple of years, and the fact that all major PTP profiles can be supported have been very positively received. The inclusion of the 40 gig layer 2 switch and 10 gigabit ports, those have also been very compelling. And then finally, the small form factor of the product, fact that you can fit 2 side by side in 1 rack slot, and make redundancy not just easy but also space saving has been very compelling, as well as PoE plus, and that the design is customizable. Now, today we talked a lot about the packet timing portfolio. We talked a little bit about antennas and the kitting, but Protempis, having been in the industry so long, also has all kinds of different flavors of timing receivers and modules, as well as different types of antennas. So check out our website to see the full line. And in terms of resources, we highly recommend that you follow us on LinkedIn, because that's where you're going to see the most frequent updates about product solutions, different videos, and so forth. Number two, we have a YouTube channel. Check that out. It has useful videos for our latest products, and then data sheets and user guides. Those can be found at our website, and you see the URL there. If you're interested in a demo of anything that we showed you, we do have field application engineers across the world, so they can do online, or they're happy to also make visits. Go to our website and click on the Contact Us section of the website, and we will get back to you within a day or two, business day max. This is some direct contact information. So Ed's information is there. But you also have our US key account manager and Europe key account manager, Brad Lynch, listed there. And then a couple of our FAEs for North America and Europe. We have additional personnel in Asia as well. So again, use the Contact Us form on the website. That's the fastest way to get to the right person. And with that, on behalf of Edward Rodemski, my name is Darshan Shah. I want to thank you very much for your time in viewing our presentation, and we look forward to hearing from you. Thank you.